Hello, everyone. Welcome to the RAIN Africa final workshop for 2024. My name is Caitlin Corrigan. I'm the Executive Director at the Institute for Ethics and AI at the Technical University of Munich here in Germany. And I'm very happy to get to introduce the final webinar of the RAIN Africa, which is an initiative that has gone on since 2020 now, from our partners, led by our partners at KNUST in Ghana and ourselves here at the IEAI. I'm going to quickly pass it over to Jerry, the director of the Responsible AI Lab at KNUST, who will introduce us to our keynote speaker today, as well as our panel. Jerry, please go ahead.
Okay, thank you. Thank you so much, Caitlin. It's always great joining together on the Responsible AI Network workshops. Today, we want to focus on responsible AI and inclusivity. And we are doing this work in collaboration with the Responsible Artificial Intelligence Lab and the Global Disability Initiative Hub of the University College of London. So we have RAIN, we have RAIL, and then we have UCL. So today, it cuts across a number of institutions. We will have the keynote given by Professor Catherine Holloway from the University College of London. After Catherine's presentation, we will have Dr. Justice Owusu-Agyemang make a presentation, followed by Mr. Dixon Ofosumafo, and then we will have Dr. Emmanuel Ahini, and then we will have Mrs. Betty Ponyo also come in to make a presentation, after which we will enter into the discussion session where you ask as many questions as you want to ask our panel. And so let me begin by introducing our keynote speaker. I have a profile here and I will read it out. And so Professor Catherine is the co-founder and academic director of the GDI Hub, where she leads the innovation and data and evidence cluster of the AT 2030 program. She spearheads innovation projects like Innovate Now and the AT Impact Fund. Cathy contributed to the WHO UNICEF Global Report on Assistive Tech and serves on the WHO Technical Advisory Group for Assistive Technology and the EPSRC Strategic Advisory Team for Healthcare Technology. At UCL, she is a professor of interaction design and innovation at the UCL Interaction Center and co-director of the WHO Collaborating Center on Assistive Technology, and led design of the MSc in Disability Design and Innovation. He develops novel technologies for disabled people globally, focusing on AI haptics, mobile technologies to address poverty and inclusion. Catherine will be talking about emerging technologies in assistive tech. At this point, I will hand over to Catherine to take it away. Over to you, Cathy.
Hi, everybody. I hope you can hear me okay. I'm just going to share my screen. There's always the first point of failure of any talk. There we go. We're on track. So thank you for this opportunity. I'm told that this network, which I'm only first joining, is a mixture of people who are interested in AI, and that today some people will be here who know a little bit about assistive technology. So I've tried to cut a line between not getting too technical in the AI, but try to find one particular example that might bring to light some of the challenges that AI has in deployment, as well as some of the opportunities that AI brings for persons with disability globally. So first of all, just to really highlight, and this will come up again in the case study that I'll talk about in the second half of the talk, that an assistive technology, people sometimes think of a wheelchair, maybe a white cane, maybe the glasses that I'm wearing, or a particular type of robotic interface, or maybe a smart home interface. And you can think of those things as products. They're just bits of kit that we can buy and purchase, but they're not often very usable unless people are taught how to use them. So the World Health Organization is very clear that just providing products is insufficient for an assistive technology. That is an assistive product. So for an assistive product to become an assistive technology, there must be a service wrapped around the assistive product, and that must include repair as well as other aspects of being able to use your device. And this might seem most obvious in educational settings like learning to read Braille, or maybe when you've had a complex spinal injury and you're learning to use a wheelchair, but it's equally true on the humble smartphone when things are deployed. Augmented communication devices, for example, are deployed on a smartphone. So moving on, I thought I'd pick a couple of questions that I'm often asked and just sort of talk to them a little bit with a couple of slides before diving into the case study, which is about a communication aid, which has been developed by Google and was deployed in Ghana, which seems topical for today. So what are the emerging trends in AI which will or could impact disabled people or persons with disability? So on the one hand, we are going to have the ability to create or interact with a wider range of information types, text and image and audio and videos. Models will become available just yesterday. I think it was yesterday I spotted it, or I spotted it yesterday on LinkedIn. It might have been released a couple of days sooner, but Sakib, who's a visually impaired coder at software developer at Microsoft, has developed automated ability to annotate videos for visually impaired people, and that's freely released. That's been built into Copilot, Microsoft's Copilot, but it's freely available via GitHub for any of us to begin to use. In terms of text, the development of small and powerful models that are easier to fine-tune and therefore run on smaller devices. So there's a couple of names there of the ones that we use. But they're allowing us to develop things a lot quicker, but also deploy them on infrastructure that maybe is not as advanced. Within vision, we're getting much faster and more robust computer vision models, which are allowing us to segment a lot of things. And these allow us, for example, we do some work in shared control of wheelchairs, where wheelchairs can have some sensors on the chair and some inputs from the user, and you're blending those inputs in order for the wheelchair to move through space. Then these computer vision models allow us to segment the space a lot quicker and build faster and more efficient models. We're also getting significant improvement in robotic controls and algorithms, and we obviously have the advent of agent-based systems which can perform at higher levels. Sorry, I'm just admitting random people so I can see my slides. The opportunities are great. I mean, generative AI has boomed, as we all know. We saw all of the tech giants fighting for space over the last year or so. But that also allows us to do speech recognition and translation. In the example I'm going to go into in a little while, I'll be mentioning in particular when you have dysthartic, which means slurred or difficult to understand speech. It's also supporting improved brain-computer interfaces, better personalized learning, and that can be for people with very special needs in terms of education, and it can also be for mainstream education. For example, we are clearly I'm seeing students that use things like Speechify, and they're listening. People with ADHD or dyslexia are listening to text much more quickly than they were going to be able to assimilate it by reading. We have image and scene descriptions, which obviously have applications for visually impaired people, and also far more intuitive interfaces. So more intuitive interfaces with elder care, cognitive and sensory disabilities. Finally, it's lowering the service cost. So where information is becoming more easy to understand, so you can chat to a PDF document, you can chat to information, and thereby get better or cheaper legal advice. We also have wider access to things like therapy or educational companionships, and in computer vision, obviously navigation and visual understanding. Prosthetics and personalized devices are being rapidly advanced. The ways that we are providing services in, for example, Gaza at the moment, is being advanced by mesh capture and creation and modification, being able to remotely capture data, which is very complex. A stump at the end of a prosthetic leg is a very complex surface to capture, and to be able to mold a device and fit it in person, but make it remotely is supporting different models of provision. And of course, robotics are getting more reliable, they're getting more generalizable, and we have more predictive robotic aids. However, there's massive risks. There's absolutely massive risks for disabled people. So the biased data sets are a massive problem. Disproportionately, persons with disability are not included in data sets. Therefore, obviously, they're either not visible when we generate things from them, or they're not usable by people. That's also the case across geographies. And there's this wicked link between disability and poverty. So if you are poor, you're more likely to be disabled. And if you're disabled, you're more likely to be poor. And that happens at a geographic level of a country, as well as an individual or family or community level. And so we are getting biases which are compounded by the fact that only richer nations or richer communities are able to give their data into data sets. There's also a problem with data privacy and copyright breaches, especially if we get into brain control and mind interfaces. Who owns scans of your brain and copies of how you think? Who owns that data? Who should have rights to be able to access data that could, for example, begin to get into things of what you might in the future, predictably what you might be thinking. There's also a problem with people just not understanding what they're signing up for. They don't fully understand what's happening with their data. So even when they give consent, it's not truly informed consent. We're getting an increased digital attack surface risk, greater risk of employment or value-adding tasks being outsourced. So maybe people who traditionally have been, unfortunately, disabled people or users of assistive technology have been disproportionately eliminated from education, and therefore doing jobs that potentially now will be taken away. We're going to increase reliance on digital systems, which if you're not able to operate digital systems will be a problem. An increasing importance of socioeconomic status. So basically having the device. We all take for, sometimes it can be assumed that everybody has a device that is usable, that is connected to the internet, that has electricity, that can be used. And obviously there's a risk of malfunction and unintended consequences. So just as an example, there's an awful lot of chatbots out there now for being able to design charts, for example, for visually impaired people. You can begin to input, several levels of AI can help. Firstly, in the search, you can now get search engines can help you identify better libraries, and then you can use things like ChatGPT to begin to write the code, and you can also use ChatGPT and others to find more information. Of course, the problem is that a lot of this information is based on what's already available publicly, and so there will be biases in that. There's a quick video of some really brilliant, lovely robots working in mobile allowers, doing some great work, which can obviously help us all at different points. However, you could argue that this is going to only be available in very high income settings in the foreseeable or the near future. So here's a video which I'll quickly play, and then I'll just share the case study in the last few minutes of the work that we did on the back of this video. So this video is of a project that came out of Google trying to help people who have dysarthric speech be understood better. Let me know if you can't hear it. Maybe it's just running. Maybe I'll just quickly, we should have checked it beforehand, I'll quickly relate it. Project Relate, Google Relate, they trained a large language model on dysarthric speech, mostly collected in North America and the UK. And therefore, people with slurred speech can be understood using the device. So this device, it's just a mobile application delivered on Android. If any of you have an Android device, you can go to the Google Play Store and you can download the Relate app. And then you have to speak to it, record 100 phrases. It works better if you record 500 phrases. And if you record those 500 phrases, you can then use it. So as you go out in the street, you can talk to your phone and it will understand you, and it will either go voice to voice and replay what you said, but in more easy to understand speech, or it will type the message on the screen, which is brilliant. And a lot of people in the UK and the United States are using it, and people with motor neuron disease, ALS, cerebral palsy, or people who've had a stroke are really genuinely feeding back that this is a great thing to have. One thing to remember, though, is as an assistive technology, it's a communication aid. So it sits between me and, say, you, and it aids the communication. But when you look at me, if you are looking at me right now, you're taking in a lot of other things. There might be eye contact, you might be looking at how my hands are moving, you will notice how my lips move, and you will also hear what I say. So the only thing this bit of kit does is take the audio and relay the audio. It doesn't take away from any of the other things. And that's interesting because the way these things are measured at the moment is on something called word error rate. And actually, it's not on whether somebody communicated and somebody actually understood somebody. It's simply, were all the words correct? But people can understand without having to know all of the words. And actually, some words are more important than other words. So it's a bespoke language models and an automatic speech recognition for people with dyslexia. Project Relate for non-standard speech. It does automated real-time transcription. It facilitates interaction with Google Assistant. It enables voice typing for SMS and other functions. And it does speech recognition using a synthesized, easy to understand voice. So a bit of background, about 28 to 49% of people with disabilities worldwide experience difficulties with communication at some point in their lives. Impaired speech is often associated with severe stigma, most with communication difficulties amongst the most marginalised groups in society due to existing barriers and discriminatory attitudes. Those discriminatory attitudes generally mean that if you have slurred speech, people think you're more stupid or you're less intelligent or you're drunk. They tend to not take you seriously, which is a genuine problem when you're trying to get through life. And in Ghana and other West African countries, these barriers are often more pronounced because there's a lack of speech and language therapy services. There's only about 30 to 50 estimated speech and language therapists for the whole of Ghana. And there's poor availability of the standard assistive technologies because those standard assistive technologies are incredibly expensive, $5,000 to $10,000. So they don't generally exist. And there's also some stigmatizing cultural beliefs. So some people believe, especially with communication difficulties, that there's been some sort of curse on the person. So our research question here was, what are the mechanisms that determine differences in access, capacity, and motivation among users of Project Relate in Ghana? We conducted a 6-week study involving 10 speech and language therapists and 20 adults with communication difficulties. What's important here is that speech and language therapists was a case of train the trainers. So it was myself, an occupational therapist and speech and language therapist, one from Japan and one from the UK, all came to Ghana to work with Gifty Ayoha, who is a speech and language therapist in Ghana. And she organised and helped us connect to 9 other speech and language therapists whom we trained, who then went on to do the training with 20 adults with communication difficulties in and around Accra. So in line with other HCI studies examining the use of mobile phones amongst marginalised populations, we leveraged the lens of technology amplification theory to analyse data collected during training. The technology amplification theory, for those that are not in the wonderful world of human-computer interaction, states that technology doesn't, it's agnostic. It comes into society, but it will amplify any differences or any trends that already exist. And so therefore, if there's already a discrepancy between one group and another group, oftentimes technology will simply make that gap wider. Whereas if in communities there's a smaller gap, it can potentially amplify a change much more quickly as an entire community. So what we found was there were these 3 different types of differential differences, if you like. Differential access to the application and its features, which was determined by actually accessing the application was determined by how bad your speech was and the presence of other functional impairments. So as an example, there were some people due to cerebral palsy who were unable to fully hold their trunk stable, and therefore you couldn't have a consistent distance between the phone and the person speaking. And that was very problematic because when they started to use it, sometimes they got excited and that would cause a slight jerky movement, which would move and then it couldn't be used again. It also depended on the type of phone. So obviously phones that had faster processors and more storage and were higher spec worked better. The availability of data, which was no surprise, and the language of the user, as well as their conversational partner. I mean, the obvious elephant in the room here is that this is only available in English. And we are working now with colleagues at the University of Ghana in trying to collect Ghanaian languages so that we could build our own open source version of Google Relate for Africa. Differential capacity was affected by the person's literacy. So their actual capacity to use it, some people's both language literacy and also digital literacy skills, people's ability to create and record customized sentences. So obviously jollof rice, for example, is not loaded into the dictionary of Google Relate. And so you have to make these custom cards, and it was a bit of a complicated procedure and some people were unable to do it. The stigma preventing people from interacting and communicating with others beyond their immediate circle. So people used the device a lot in situations where actually they were already understood by people, and they were sort of scared to use it in a public place because they thought they thought people wouldn't accept it, or they tried to use it and people wouldn't accept it. And there was also different motivations between people. So individual specific life circumstances caused changes in how motivated they were to use it. If they had no reason to communicate to anybody else because they weren't in education and they had no job, and the immediate people around them could understand them anyway, then there was no real motivation. Whereas one woman that we worked with is a human rights lawyer, and she was very determined that she should be able to work as a lawyer. And so she was determined to use it and very motivated to do so. So I'm going to conclude here. We went back to Google. I'll just summarize here. We went back to Google with 3 recommendations, working on understanding the contextual nature of language, considering all the stakeholders and sort of acknowledging the strengths and the limitations of ASR. And also went back to Google to show them things like the mission of Adwa, the human rights lawyer, is that no one like her has to struggle like me. I don't want anyone to go through what I have, but until now I could not get my message across like I wanted, and I have tried many things. So that's it. We're now working with Google to do a number of things, to collect custom cards in 3 countries across Africa, bulk import them, to collect 10 African languages, and to make sure that there are at least 100 apps that will come out of Google Relate that will be specific to Africa. So I shall end there. We always end with this slide, which is "We can change the world," and you can follow us on socials, which I never understand. But thank you very much.
Thank you. Thank you so much, Kathy. Indeed, we can change the world. This is fantastic. Okay, so it's getting more and more exciting. We will move on and then pick the next speaker, Dr. Justice Owusu Ajiman, and I go ahead with his profile. Dr. Ajiman is a lecturer at the Kwame Nkrumah University of Science and Technology, Ghana. He received his BSc, MSc, and PhD in telecom engineering from KNUST. His research interests include Internet of Things, network and application security, blockchain technology, AI, and applied cryptography. He is currently exploring field of quantum computing and information sciences, and is a certified Huawei ICT associate instructor and ICSI certified network security specialist. His skills and expertise make him an outstanding cybersecurity consultant. He specializes in reverse engineering networks and application security and blockchain security. Driven by a passion for protecting against cyber threats, Dr. Ajiman is a pioneer in cybersecurity. He creates advanced solutions for optimal protection and security for his clients, and his innovation and commitment to excellence makes him an exemplary figure in his field. Dr. Ajiman is the Assistive Technologies lead for the Responsible Artificial Intelligence Lab, and we will listen to him regarding what he is doing as far as IWheel is concerned. Over to Justice.
All right, thank you, Prof. Okay, so good afternoon, everyone, depending on where you're coming from. Yeah, so I'm going to give a very brief, should I say, a talk on what we are working on in terms of empowering mobility. That's like developing an affordable assistive intelligent wheelchair for PWDs, mostly targeting developing countries. So these are my team members. So I have Dixon, Gloria, and Husky. Yeah. So for the agenda for what I'll be talking about, I'll just give a brief background to what we are working on, the research approach that we are trying to use, the next steps we have, and also the conclusion. So from the GSS reports we had in 2021, you realize that we have approximately 80% of Ghanaians who have some form of disability. And then you can see there's a high prevalence of among females as compared to males. So if you check like 8.8% is to 6.7 roughly, maybe 1:1, but then kind of close. Now, if you look at the situation we have in Ghana at the moment, when you interact with PWDs, what you kind of find out is that one, the kind of devices they use to enable them to move or to be able to enable them to do whatsoever they defect a little bit in are not that okay. And then this is due to some base reasons. One of them can be to the fact that if they want to get something which can suit them, it's quite expensive. And some of these assistive devices are unavailable per certain in Ghana. And for some of the solutions that we have out there, they lack adaptability to local conditions, I mean, per our settings. And also there's a technological gap. Interesting to know that not all of them are quite like educated in some way. So when you develop a solution which the tech is quite too much for them, there's no way they'll go ahead and use it. Now, these are the key issues that we find out in our setting, and then we decided to see, okay, what can we do to be able to help these people? So our focus is mainly on the physical mobility part, those with a physical impairment. So we decided to do our research approach involves a comprehensive needs assessment, where we did some review of existing works, and also we have a stakeholder engagement also over there. Then based on what we have, we'll be able to come out with an affordable AI-driven wheelchair prototype, and then we'll go through an iterative design phase to be able to test it, get all the things we need, and then tailor it to the use case that we have in Ghana. So for our comprehensive needs assessment, that's like the phase one of it, we decided to look at what actually exists in literature. So per what we find out, we decided to categorize them based on the features. So when it comes to wheelchairs, what have been done so far? So we realize we have some control mechanisms, some ergonomics, the power source, the way the devices are powered, the health and safety of the device, and then how cost-effective the design is, and also the security features within it. So in terms of the categorization, for instance, for the control parts, we had some people proposing speech recognition, which I think we saw quite a number of works which involves like text-to-speech and then some NLP related stuff. And we also have the brain controlled wheelchair, that's the BCW, and the eye tracking, the head motion, tilt motion, and also the hand gesture. These are controls that people have proposed aside the normal joystick that you can use to steer the direction of the wheelchair. Then we also saw some people touching on the rest of it, which has to do with the posture adjustment, and then stairs traversal, some extra fancy stuffs like entertainment, bed docking. So for the bed docking feature, it can determine if someone is out of the seat and then maybe switch to low power mode, and then you can be able to dock it close to the bed. And then for safety mechanisms, some people integrated like obstacle avoidance and means to monitor the health vitals of the individual, and then some other extra stuff. So in terms of power source, some of them were trying to see, for most wheelchairs, you can have like a battery unit that powers the entire system. So they were trying to leverage on other forms of energy and then do a transaction and then use that to charge the onboard battery systems. So some of them were using rotational motions and then braking activations, motor reversals to be able to generate some form of power and then use that to power the device. So in terms of the cost-effective design, some of them were looking at portable kits. In our case, as Ghanaians, most of the people who use these wheelchairs, like the first image I showed, use the manual one, right? So if you decide to go build one from the scratch for them, that means they have to throw what they have. Now, if you want to design something which is cost effective, you might decide to see, okay, this is quite affordable, that's what they can afford. how do you convert that into something that is quite smart for them to use, right? So some people were proposing the portable kit idea, and then some were saying, okay, yeah, you can just go ahead and design a new thing from scratch. So these were some of the things we found out when we were doing our comprehensive needs assessment. And then we also looked at the security aspect of it, because with the whole AI-driven aspect, communication aspects, and then all the sensors involved, yeah, we need to know what kind of secure communication strategies needs to be put in place. Yeah. So some also proposed some mechanisms, but I think for the security aspect of it was quite low because most people are just more concerned about the convenience part of it and then how to get it working. So per the initial needs assessments that we did, we decided to tailor it to fit into the case of developing countries. So with what we have so far, we are considering two scenarios. So the first scenario is for what they already have, can we retrofit that and then make it smart? And then two, we can go ahead to design an affordable one. So we want to adopt two approaches that covers the two scenarios I've mentioned. So the core features we'll mainly be looking at is the motion control, the ergonomics parts like what we had, and then the sensor power requirements, and then some additional design features, which might be fancy, but then, yeah, that will come later. So the first three are the main things that we are actually focusing on. If we're able to do that, then we can go ahead to add some extra fancy stuff. So currently what we've done so far is to come out with mock-up designs to see how, if we pick the normal one, how do we then convert it or retrofit that into a smart one, and then be able to see how we can make it quite affordable for people to use. So we'll have the ability to let people bring in what they have. We just make it smart and then hand it back over to them. So for us to be able to know what people really need, what are the use cases we have in mind is actually okay for them, or might really suit the Ghanaian who has this kind of impairment, we have a stakeholder engagement meeting coming up where we are going to interact with them, get to know. With some of the mock-up designs we have, yeah, we will end up showing it to them to see if it makes sense, would it be okay for them? And then based on the feedback that we get, it will influence what we are going to do, and then we'll be able to come out with some better mock-up of the prototype. That is for the phase one part of it. Then be able to design something that suits the Ghanaian setting. So that is, in summary, a brief summary of what we've been working on so far in terms of trying to support PWDs who are physically impaired. Thank you very much.
Thank you to Dr. Justice Owusu Ajiman. Looking forward to how IWHEEL will turn out. Well done. Okay, we will move on and then pick the presentation from Mr. Dixon Ofosu Mafu. I'll read a bit about Dixon. So Dixon is a dedicated MPhil research assistant at the Responsible Artificial Intelligence Lab at the Kwame Nkrumah University of Science and Technology. His primary focus is on research concerning the application of AI for social impact. Currently, he is actively engaged in the Responsible and Inclusive AI team at REAL, where he specializes in researching adversarial AI. Additionally, he contributes as a team member to a project developing AI-powered assistive technology for both visually impaired and differently abled persons. He is currently pursuing an MPhil in telecom engineering at KNUST and building on his academic foundation with a BSc in the same field. Beyond his research commitments, he has served as a teaching assistant at KNUST, and his technical expertise is further evidenced by his certification as a Huawei Certified Network Associate. Over to you, Mr. Dixon Ofosu Mafu. Let's hear what you have for us.
Okay, that was an elaborate introduction, Prof. Thank you very much. And good day, everyone. I'm Dixon Mafufusu once again from the Responsible Artificial Intelligence Lab in KNUST. And it's a pleasure to be here today. And over the next few minutes, I'll take us through a presentation on a project the lab is currently working on. So this is an assistive technology for the visually impaired. So let's just get started. Okay, so let's begin by looking at a stark reality of visual impairment. So we can see, according to the World Health Organization, there are an astounding 2.2 billion people worldwide who are living with visual impairments in 2024. To put that into perspective, this figure is approximately 27% of the world's global population. And this is also more than a quarter of the global equivalent to the combined population of China, of United States, and Indonesia combined. Now, this will definitely have an impact on everyday life. So tasks that are seemingly as simple as reading, say, a medicine label or moving around seamlessly becomes a real challenge to these people. So our project that I see is focused on developing assistive aids to help these particular individuals with visual impairment. So we are not just creating technologies, we are providing opportunities for independence for these said groups of people through innovative AI-powered solutions. Okay, so to my next slide on key visual aid solutions. Now the question is, I've made mention of AI. How exactly can AI help? Now we focused on two fundamental solutions or fundamental needs, navigational and observational needs. So now navigation is more concerned about moving safely and confidently from one point to another, avoiding obstacles as well as finding your way around. Now the next, which is the observational need, has to do with you being able to read text or understanding your environment visually. So we believe by categorizing and addressing these, we are not just providing tools or gadgets, but we're actually making a contribution to autonomy so far as these two contexts are concerned. We can also consider a hybrid solution, which we will talk about in the next slides. So for our project aims, our approach is guided by three key concepts. So one, we are aiming to develop an intelligent solution. So our plan is to develop a cost-effective AI-powered device that genuinely solves the problems and the challenges that people face. Now, the next is an inclusive solution. So here, our work is rooted in enhancing quality of life and ensuring that no one is left behind, as is the case in developing and third world countries. And three, we are aiming to develop a context-based solution. This is actually crucial. We are planning to design these technologies to fit seamlessly into the unique cultural and environmental conditions present in Ghana and other similar regions. So we believe by focusing on these project aims, you'll be able to, one, develop an intelligent, two, an inclusive, and three, a context-based solution for a lasting impact. And over to our concept design. So let me just try painting a concrete picture of what we are working on. So for this project, we have three potential solutions. The first is a navigational aid. So we are considering a smart cane for navigation, which will be equipped with features such as obstacle detection and pathfinding. Now, our second scenario has to do with an observational aid. For this one, we are considering a smart eyewear for observational tasks using computer vision technologies such as object recognition and text-to-speech. Now, our third scenario is a hybrid between the navigational aid and the observational aid. So for a truly comprehensive experience, this is what we are considering. Say a visually impaired person who will not just be able to move from point A to point B, but would also be able to recognize the environment he or she finds himself in, read and react to signs which are very important in our environment, as well as identify obstacles and environments. The other key considerations that we also made that will also be taken into consideration so far as the design solution is concerned. I'll just make mention of some of these features which we are considering, which include not features per se, but I mean considerations, which includes the ease of use of the solution we are going to develop, the durability so far as the Ghanaian and similar environment context is concerned, battery life, cost effectiveness, safety, maintenance, accessibility, as well as various features which you would try and incorporate into this device of ours. So here's where it gets really interesting too. None of this will be possible without input from the people who truly matter. That's the users of these particular assistive devices. So we are having a participatory design for this particular project, where we are engaging directly with these visually impaired persons to understand their needs, their frustrations, their hopes, amongst others. So with this, we envisage a technology that does not just sit on a shelf in the lab, gathering dust and rusting, but actually something that's going to help these persons gain more independence and autonomy and be able to feel well connected to this world around them. So all right, so in closing, the IC project, as I said, is about responsible AI and inclusivity. A technology that just does not seem to exist, but truly empowers people. So thank you very much for your time.
Thank you to Dixon for that elaborate presentation. So we've heard of I will, we've heard of I see. Hopefully, I'm wondering what the next I will be. We want to move on to the next presenter, Dr. Emmanuel Ahene. He holds a PhD in computer science and technology from the University of Electronic Science and Technology of China, with research interests spanning machine learning and cybersecurity. With almost 4 years of dedicated research experience in machine learning. He's the principal investigator for Science-to-Text Speech project dubbed SciTalk. His innovative initiative focused on digital inclusion aimed to develop a communication platform that bridges the gap for individuals with speech and hearing impairment, providing them with essential communication tools. In addition to SciTalk, he leads the Deep Learning for Food Sustainability project, where he applies advanced AI techniques to enhance agricultural practices and promote sustainability. His role as co-PI for the MESTI mHealth project further demonstrates his commitment to leveraging technology for social good and works to improve healthcare access for undeserved communities through mobile health innovations. I want to introduce to you Dr. Emmanuel Ahene. Dr. Ahene, please.
All right, thank you so much, Prof. Am I audible, please?
Yes, we hear you loud and clear.
Thank you, thank you. Good afternoon from Ghana to everyone, and I'm grateful that this has been given as an opportunity for us to present on what we are doing. So I'm sharing my screen now. All right, so yeah, I'm going to talk about SciTalk. This is a project that is aimed at bridging communication gaps between doctors and people who are hearing and speech impaired. And the objective is to actually ensure that we promote inclusive healthcare in Ghana. This is the team I'm working with. And in the few minutes from now, we are going to be looking at some background to this particular research and what we are looking at doing and the concept design. So typically we know communication is inevitable for everyone in life, and that's how we express what is within us to others. And unfortunately, we are having some group of people who are speech and hearing impaired everywhere we find ourselves in the world. So the World Health Organization has an estimated figure of about 430 million people across the globe who are speech and hearing impaired. And also in Africa particularly, it's estimated that about 136 million people are in this category. But when you come to Ghana, we know that there are about 470,000 and over people who are speech and hearing impaired. And the problem we have here is that most of these people are receiving suboptimal healthcare provision. In fact, the problem is typically most health facilities do not have experienced or qualified people who can do signing and help, the communication, help bridge the communication gap between the patients and then the doctors. So this has resulted in a lot of negative effects, including mortality. And so the issue actually requires some innovative intervention to ensure that we are able to bridge this communication gap. And that's what we are looking at in this project. So we decided to, first of all, go to the people and then hear from them what is going on. Basically, when you are with the people who are speech and hearing impaired, you would find that they have a significant need for a very simple and cost-effective solution that can help them to translate sign language to text and also speech, among others, to other individuals that they communicate with every time. And then also, if you would communicate with them, you find that they want to have a system that is easy to use, okay, not so complex, but easy to use. Then it can help them or improve the rate of adoption of such an application or system. And at the moment, there is an awareness gap about existing technologies and how those solutions are going to be very, very adequate for them in creating opportunities for them in relating to people around them, especially in the healthcare area. And so this key information or findings that we get from the people helps us to understand that essentially there is a need for a cost-effective solution that can help them to communicate to people around them, and especially when receiving healthcare access. So when we look at literature also shows us some amount of work that has been done in the world and also within our country particularly. So the people in the USA and other countries outside of Ghana have advanced quite well in terms of research as far as sign language is concerned. There are a lot of wonderful developments already. But if you would come to Ghana and even in some African countries, you would see that we are actually lagging behind as far as research development is concerned with relating to sign languages. And typically what we get to understand in the study or in this research is that sign languages are not the same across countries. So they tend to differ contextually and culturally. Therefore, it is important that we have technologies that we can actually look at developing to suit the nature of or the kind of conversations that people would use the sign languages to do here within our region. Okay, so in Ghana, we have the Sign With Me, and this is basically like a web platform, but it's dictionary based. And then there is also the GSL recognition with deep learning. And this is actually in a research phase, just like a research paper that has been proposed regarding such a development. So there is actually not much done in this area. So what we are looking at is we want to look at how we can leverage deep learning techniques to develop a sign language recognition and translation system. And so this is like one half of the major project we intend to take up, because on the other hand, you would want to look at sign language production that is from speech to a sign language output. And so first we are looking at sign language recognition and translation. So if you look at the video on the right, our goal is to have a system, or simply put, a mobile application that would take a feed from either a video or a camera in real time, and then give us the translation in text. Okay, so here is a simple, architecture just to explain further what we intend to achieve. So if you look at the diagram here, you can have two input feeds. One, if you're thinking about real-time situation, then you are having a camera sign language in real time, and that could go through a segmentation model, and we feed up the sign writing from the glossy labeling, and then that can now be moved on to that level where it's converted into spoken language text. And also to improve upon it, we add the spoken language audio. And that is to say you are looking at a sign language being done and the output being produced in terms of text or in terms of audio. So you could have it done real time, or you could upload an existing video and you objectively see the output in that form. And so that is the goal or the idea we are looking at. And eventually in future, we will look at the other side, which is the speech to sign. The objective is to say, if you have a spoken language audio, or if you have a spoken language text or a language identification, would you be able to normalize it and go through all the sequences and then generate either a human GAN or maybe a skeleton viewer or a 3D avatar that would be signing the particular spoken language text or audio and so on. Okay, so what we are exploring now is we are looking at a very fantastic development that has been done so far in this field, what we call the Sign LLM. Okay, so this Sign LLM was proposed by Jargon et al. And in this work, they are looking at a very innovative way of putting videos into frames, or what you call clips, and then using two important technologies, the vector quantized visual sign model, and then the codebook reconstruction and alignment model. And the goal is that they are going to be able to put the video clips into some characteristics of spoken language, and then they pass it to a sign LLM framework, and that will transform the sign videos into a language-like representation for improved readability by open source LLMs. So they are leveraging open source LLMs, and the objective is that they want to transform, clips or videos into the form that can be read, let's say in text and so on and so forth, to enable translation of signed video into other forms of languages. Now, interesting enough, what they bring out is more of a framework, that has been tested based on their experiment and proven to be effective. And so what we are focusing on at this moment is to look at how to fine-tune our data sets and fine-tune our video data sets, and look at how to use this existing Sign LLM framework and then use it to achieve our goal or our results. Okay, so basically that is what we are exploring at the moment, but our concept is to eventually have something simple on a mobile app, which will be obviously for free, easy to download. And then what you do is to have a camera feed to capture a live event of a recording of a video, and then that should be translated in terms of sign, and eventually, if we are going the reverse way, from language text to an avatar demonstration. Okay, so a little bit of progress that we have made so far in this work is that we have been able to, again, go and gather more than 3,000 video data sets. We've gone to the people within the communities, and then we've gotten these video data sets, and we have worked on the data sets, we have cleaned them, we have validated the data sets already. And so, as I said initially, our main goal at the moment in this research is to look at how to fine-tune these video data sets, and then try to work along with the existing Sign LLM to see the kind of results that we are going to be having, and whether or not there's going to be a need for an improvement. So in conclusion, we are optimally looking at a solution that will be cost-effective and will help bridge the communication gap between people who are speech and hearing impaired and the health workers. Thank you very much for this opportunity.
Thank you, Dr. Emmanuel Ahene. We want to move on to the last presentation, and then we will enter into the Q&A session. So all those of us who have questions, note them. You will have an opportunity to either ask them directly, or you drop them as a test, and then we will read it out to the panelists. So we now have Betty. Betty is a senior administrative assistant at the College of Science, KNUST, with a master's degree in disability rehabilitation and development. She focuses on the psychological and economic effects of environmental barriers on individuals with disability and is passionate about research that identifies effective mitigation strategies. Her postgraduate research examined the impact of caregiving on the well-being of primary caregivers of children with cerebral palsy. Currently, she is the research lead for a project investigating the usage and uptake of assistive technologies in Ghana under the Responsible Artificial Intelligence Lab project, emphasizing the intersection of disability studies and socioeconomic development. Over to you, Betty. Please go ahead with your presentation.
So thank you very much, Prof. Good afternoon to you all. Assistive technology can be considered as a life-changing intervention in recent times, especially for persons with disabilities. The increase in innovation of this technology could be attributed to the rising number of people who need assistive devices, according to various literature, Ghana not excluded. It is therefore a step in the right direction for my team and I to investigate the usage and uptake of existing technology in order to appreciate the reality with regards to their uptake in Ghana. So my presentation would follow this outline. We'll look at the assistive technology's role, the usage. We will consider the barriers. We'll look at the next steps in our work, and then we conclude. So what my team and I are doing now is to review literature to appreciate what is happening globally and also in Ghana. We have realized from literature that persons with disabilities encounter various challenges in their daily lives, from reading books, navigating streets, and even communicating with friends and loved ones. The appropriate use of assistive technology will help mitigate these challenges, increasing the independence of its users and thus promoting inclusivity of PWDs. But we have also come to appreciate that various factors prevent the adequate use of assistive technology. Now, according to literature, the World Health Organization and UNICEF reports on assistive technology states that access to assistive technology is the most important requirement of usage. Now, out of the 2.5 billion persons who need assistive technology, it is realized that approximately 1 billion individuals are denied access to assistive products. And the situation is made worse and can be as serious as low as 3% in Ghana. A study reported that among 40 million amputees, just 5% have access to prosthetics. 1.5 billion people have hearing loss, yet only 10% of the global demand is met. Now, the disability growth in Ghana confirms a report which states that there is a rising number of people in need of assistive devices. When you look at this graph, between 2010 and 2022, there has been a 5% increase of disability growth in Ghana. However, we can appreciate the role of assistive technology in these situations. And we are very sure that PWDs can become more independent and integrate into the community with the use of appropriate assistive technology and equipment. Now, we went ahead to explore some of the existing assistive devices used globally. And literature reports that these assistive devices are categorized into three. We have the low-tech, mid-tech, and the high-tech. The low-tech being less expensive or the least expensive of all and does not require much training. The high-tech is quite expensive relatively and requires a lot of training and is quite complex in its operations. Now, the mid-tech falls between the two. And literature reports that Ghana and other African countries usually go for the low-tech and the mid-tech. So here are some assistive devices we found. For the hearing impaired, we have products like Captel phone, TV ears, the hearing aids. We have the orthotics and prosthetics, wheelchair, crutches, walking frame. We have the electronic and manual magnifiers, Braille, the white cane. But when we come to Ghana, we realize some common assistive devices used. We have the prosthetics, we have the wheelchair, crutches, walking frame for the physically challenged. We have the white cane, the Braille, the eyeglasses for visually impaired, and then the hearing aids. Now, and hearing aids, they are found to be very expensive. So they are not so common in the country. Whether assistive devices are low-tech, mid-tech, or high-tech, we still appreciate the benefits the users derive from it. Report has been made about increased freedom of movement and participation in activities, improved performance in academic work, and increased employment opportunities. Now let's consider the uptake of assistive technology in Ghana. We want to look at the barriers which affect the uptake. Field research that has been conducted reports environmental and physical obstacles experienced by the physically challenged especially as a very serious barrier. This is as a result of the infrastructure designs, which makes navigation very difficult. Reports also was made of the high cost of attainment of assistive devices and rehabilitation services with the use of the devices. A study on prosthetics users show that they experience discomfort or pain sometimes, or develop conditions like swelling and skin rashes when they are used. So this can be seen as a compatibility issue. In Ghana, the experiences and opinions of persons with disability with the use and non-use of assistive technology are quite underexploited. Literature states that if we want to avoid the premature abandonment of technology, especially with assistive technology, then developers and designers of assistive devices need to seek the opinions of prospective users. Therefore, investigation regarding the use and non-use of assistive technology among persons living with disability are underway. My team and I are preparing for a stakeholder engagement with the PWDs from 10 selected districts in Ghana. We would want to appreciate their challenges and even take their opinions and recommendations regarding assistive technology in Ghana. We would also like to engage the suppliers and administrators of assistive technology to appreciate which ones are common, which ones are more patronized, and why they think so. We would also like to have one-on-one interviews with caregivers and assistants of the disabled in their environment. In conclusion, we hope that the result of our work would assist interventions regarding usage and encourage the uptake of existing and emerging technologies in Ghana. And this, we hope, would ensure that no one is left behind. Thank you very much for your time.
Thank you very much, Betty. What I pick from this is that we need to ensure that no one is left behind. At this point, I'm going to open the floor, and anyone who has a question, right from Kathy up till Betty, you have an opportunity to ask. We still have about 30 minutes to go. And so feel free, you raise your hand, I will call you, or you post it in the chat, and then working with Caitlin and the others, we can read it out for our presenters to respond to. And so the floor is open. You just put up your hand and then we will enable you to be able to ask your question. Any hand up? Okay, let me start whilst we wait. Justice, you did indicate that you are looking forward to a stakeholder engagement. Dixon also mentioned that you wanted to do a design that is has the involvement of the users. Can you throw more light on your approach to ensure that there is no abandonment when you are done?
Hello, Prof. So if I get your question right, you are asking about the stakeholder engagement and then what we are doing to get all the PWDs for our
Yes,
category.
please.
Okay. So what we did initially was to come out with questionnaires, which targets like the various PWDs, I mean, per category with the physical impairment. So some from the initial analysis we did, some of them use wheelchairs, others don't. Some use clutches, depending on their condition. So the questionnaires we have is made to tailor for both cases, and also we take into consideration their level of education also. So then we'll be able to get much feedback in terms of like why they do this, why don't they do this, so that we can fit that into what we are trying to design. Now, what we are trying to design is based on what we got from literature and then per the setting we have in Ghana. But then we are trying to see if we go for the stakeholder engagement and we don't show them anything. Okay, so we go with, yeah, this is our questionnaires that we have. Okay, this is what we have in mind that we feel we could design to help you. How do you also feel about it? Then we can get like some feedback from them, and then that can also affect how we intend to go about the initial mock-up design and then other stuff. Thank you.
Okay. Thank you very much, Dr. Justice. The next one, I will go to Kathy. Kathy, thank you so much for your elaborate presentation. I want to ask a question regarding the Google Relate. That presupposes that the person must be familiar with the use of a smartphone before he can benefit from that. Is there any intervention regarding those who do not have the capacity to buy high-end smartphones? How do we take care of that? I remember from your presentation, the indication was that disability was linked to poverty one way or the other. How do we ensure that no one is left behind?
It's a great question, Jerry. It does presuppose you have a smartphone. We did some work with Google previously, and realistically, about $149 phone is what's needed for most of the accessibility features, whether you're visually impaired, hearing impaired, communication impaired. you need $150 phone. And actually, some of the lower cost phones should work, but the manufacturers, although they load Android onto the Android is accessible, but their SCIM over it isn't. So they haven't labeled the camera button in particular, which makes all of the other features inaccessible. So yeah, you end up with sort of a Samsung A7 or A8, which is expensive. And it's we do see some work happening on lower tech devices, so feature phones or button phones. They've been used particularly well in India for large scale education during COVID. So connecting multiple phones through one teacher phone and only needing button phones to continue. So it is possible, but for communication aids, generally you need the processing power, and that that begins to get you into the realm of smartphones. I think one of the other projects we have ongoing at the moment through the 80-20-30 project is just literally giving out roughly 500 phones to 250 people with hearing impairment and 250 people with visual impairments, and that's in 3 countries. So it's in Brazil, India, and Kenya. And then seeing how does that phone act as an assistive technology. And one of the reasons we're doing that is one of the partners in that project is At Scale, the UN Partnership for Assistive Technologies. And we want, Gifty's just arrived, we want to be able to demonstrate that an assistive technology should, a mobile phone, a smartphone should be an assistive technology, and therefore should be provided through government schemes to people. So if we can, as countries begin to build out, in assistive technology world, there's a thing called a priority assistive product list, and that's developed by the WHO. And countries currently are committing to products on that list. And so we're advocating that a smartphone should be on that list. And then if it's on the list, it gets given out via government schemes rather than people having to pay out of pocket from day one.
No, that is fantastic. I want to ask one more, and then I'll go on to, I think there are some questions on the chat. And still on the Google Relate, has there been work regarding how people living with disabilities have interacted with the app and what has been their feedback? I am very interested to know what the user community is saying as far as Google Relate is concerned.
Yeah, actually, Gifty has just joined the call. I see. I'm not sure if she's able to speak as a participant, but Gifty is the speech and language therapist that we work with and a good friend who works in Ghana. So she could probably speak to this better than I can because she's working every day with the people who are using the application. But we're effectively finding that in some instances it's very useful. So there was a student in northern Ghana that was using it very effectively to communicate, for example, with the dean. She was the first student of first person in her family to go to university, and the first person in the university to have cerebral palsy. And she was communicating very well with people using it. And again, Adwa, who's the human rights lawyer, is continuing to advocate for its use and really enjoying using it. And then other people haven't been able to use it so well. For various reasons, a wide variety of reasons. I see that Gifty's been made a co-host, so I think she can speak if you did want to add something, Gifty. Please go ahead.
Yeah, I was actually going to ask you what the level of...
Sorry, one thing I could just add, Joe, if you don't mind. It's just language is a problem. The language is a problem. So obviously English spoken in Ghana is not the same as English spoken in England or English spoken in America, right? So the ordering of words might be slightly different. People might mix languages like Twi and English. You might have some words that are swapped in and out. And so it presupposes that everybody speaks English, only English, and English in a way that American or British English speakers speak it, which is not the case in Africa. So that's it. That's the other issue. Sorry, Jay, back to you.
Thank you. There is a question in the chat. Okay, a question for anyone. So what is needed in AI governance mechanisms or policy more generally to improve inclusivity in technology, both in terms of mainstreaming and targeting tools? So one of the participants is asking what needs to be done from the policy angle to facilitate or enhance inclusivity? Any of our presenters can pick it up. From the policy angle, what do you think needs to be done?
What do I think needs to be done in terms of policy?
Yeah.
Policies are great, and they often exist. I know that Gifty's worked quite hard on just getting a speech and language therapist to be paid for by the Department for Education within Ghana. And that's a start, right? But there needs to be central services embedded into the education system as well as the health system. And for that to happen, you need the policy, but you also need the budget. And I think one of the biggest issues is budget. That's just everywhere you go, trying to get budget confirmed for assistive technology is very challenging. It's a very difficult thing to sell to people because if you're in health, Yogi, if you're in health, if you're in health, then if I want to sell you a new cancer treatment program, the thing I will sell it to you on is I can save this number of lives or I can extend life by this many months, right? When it's assistive technology, we don't have clear-cut statistics like that. We're talking about improved quality of life over a life course. We're talking about people being able to just live their lives. And it's very hard to then secure the budget against neonatal care, cancer, HIV treatment, and everything else. So the best way forward is to approach it through a human rights-based model, but often that's not what people take. So in Norway and Sweden, they have a human rights-based model, and that works very well. So I'm going to be quiet for a minute while I try and shut my dog up.
Thank you very much, Kathy. There is a question on data sets. I'm going to direct that to either Dixon or Dr. Ahene. The question borders on elaborating on how the availability of data affects users' access to applications. Let's start with Dixon. Dixon, how is data sets, the paucity of data sets, an issue as far as your development is concerned for assistive tech?
Okay, so thank you, Prof. So we are looking at developing a solution for visually impaired persons, and from our concept designs, it looks like we'll be having computer vision technology in here. Now, driving a key, should I say, feature of computer vision is image data or video data or multimedia. So in this particular context, we will need local data. We will need to collect local data, and we cannot really rely on data that has been outsourced from external regions. This data should be representative of these particular groups of people that we are developing our solution for. We have let's consider a solution where we are trying to develop a model or train a model that's going to understand our peculiar problems in Ghana. Let's say potholes. If we don't have the data for potholes to train our device to see a pothole, we may not get a data that's representative of a pothole in a generalized data set. So in this, we have to now see what is out there, then augment what is out there with what fits within our particular scenario, then train our models to be able to actually be representative of whoever it is that this solution is being tailored for. So that's what I'll say about data. The data is not fully out there, and we plan to move out after our stakeholder engagement, after defining what solution we want to develop, go out for the data that's really representative of the solution we want to develop, then train our models to actually work in that regard. Thank you.
Thank you very much, Mr. Ofosu Mafu. I move on to Sign Talk. Dr. Ahene, there is a question for you. Concerning Sign Talk, once the final product is ready, will it be a paid service? Since the model needs to be hosted somewhere, and if the model will be bundled together to run locally on the phone, wouldn't the smartphone then become a barrier? Dr. Ahene, please. There is a question on the final product, whether it will be a paid service or you will do it for free.
Okay, thank you very
much. Dr. Ahene.
Yeah, thank you very much for the question, Prof. So basically, with the understanding we have in the project development, there's no idea of making it a paid service, because optimally what we want to do is to enable easy access to this particular intervention to ensure that people who are speech and hearing impaired can have very good access to healthcare services. And as you rightly commented when Prof. Catherine was giving a presentation, there is some bit of a link between, poverty lines and then people who are, in that disability group. And so you don't want to really be going with services that is demanding some level of money or some commitment in terms of money from them from a higher point of view. And so you would really have a very low rate of adoption if you are looking at monetizing this particular product. So as far as the project is concerned, and that's why we are receiving sponsorship and everything for this. So as far as the project is concerned, we don't have it as a plan to make it a paid service. If even it comes to the point where there is no resources, we may have to adopt a new approach of raising funds, either through donor approach or any other form, to just ensure that the solution is completely made free for those who need it. And yeah, so also with respect to what we are exploring, we are not looking at a very highly computational intensive system that would basically be requiring some highly resourced mobile device, for whatever scenario it may be used for. And so the process of development, we are very critical about that, because we know in the end, if you're going to deploy this on a mobile phone, you also have to again look at the users and the user community. How many of them can afford buying an expensive mobile equipment? So you want to look at how you come up with this solution so that you have at least some good or low resource mobile phones being able to use them as well. Thank you very much.
Okay, thank you very much, Dr. Ahene. Betty, I want to ask regarding your interaction with persons with disability, those who are hearing challenged, those who have visual impairment, what basically has been their challenge with reference to existing devices on the market?
Okay, thank you very much, Prof. For the hearing impaired, we had an interaction with the leaders of the Association of the Persons with Disability in the Ashanti region, and we wanted them to sample about 50% of the participants who use hearing aid. And I should say, to my surprise, I was told that none of them uses hearing aid. So I went ahead to find out whether they have been checked medically to be sure that they couldn't use it. And that wasn't the issue. The issue was that it was too expensive. It was too expensive. So I think for them, for now, what I can say, until we engage them at the stakeholder engagement properly, the whole issue has to do with cost. But for the visually impaired, I think the situation is a bit difficult, because for them, they need, especially for the ones who are totally blind, they need some kind of advanced technology to help them navigate their environment. Because when they use the cane doesn't do much. As I presented earlier, it's a low tech. It doesn't do much. Navigation is difficult. I had one of them telling me that even when they have to take transportation from one place to the other, they have to pay more, because they would have to get a car for themselves and pay it, a drop-in of a sort. So it's difficult. The same goes for the mobility challenged. They are also complaining about even access to transportation, when they have to board public transports. There's a lot of grumbling here and there as to why they are going to frustrate the other passengers with their burden and all that. And when you interact with them, they also talk about costs, the cost of maybe a higher or an advanced assistive technology, which will help them go off the crutches, because most of them use the crutches in Ghana. And the manual wheelchairs doesn't do much in terms of navigation. So basically, what I see is the costs is a major problem for most of them. Yeah, thank you.
Okay, thank you very much, Betty. I'm going to, my colleagues who are working on IC, Dixon, with reference to, there is a question in the chat asking what are the limitations of the visual aid device that I think Betty has mentioned, but there's a question that would the assistive device be able to aid a visually impaired person on grocery shopping? If I go to the market and I want to buy groceries, will your solution be able to assist in any way? Thank you.
All right, so thank you very much. So one thing I'll say about this is it will be very beautiful to have every feature out there incorporated in the device. But one major thing we are actually focusing on is a cost-effective solution. And as researchers and as ethical researchers and developers, we included the participatory design so that we will know what these persons we are developing the solutions for actually need. So after gathering our data, we will just go through, analyze the data, then see what features would actually be relevant for these particular groups of people. I think as a team, when we start to discuss which features to include and which not to include, I think one major thing that we came up upon, one major agreement you all came to was a progressive solution. So our initial solution may not have every feature infused in one device. We could have different iterations of designs, or we could have different design devices that are actually supposed to do different things. So it could be, let's say, an eyewear that's for text recognition. We could have another eyewear for tailored just for let's say the grocery shopping in this particular context. But for the meantime, I would say we as developers, our main focus is on navigation, because I think that's really basic. But from time to time, I think grocery shopping will be a very beautiful feature to train and model on. So it's something not out of the box per se, but something we can consider from time to time. Thank you.
Thank you very much. If there are any more questions, feel free to drop it. We are just about ending. But I'm going to Justice. Justice, you did indicate there has been issues relating to cost as far as assistive devices is concerned, and you are indicating picking the ordinary wheelchair and retrofitting it and giving it some intelligence so that the ordinary person can afford it and also make them inclusive. Are you able to provide us with cost savings between your solution and already existing intelligence solutions on the market? Justice, please.
Hello, Prof. Thank you very much for the question. For now, no. But then I think once we are done with our mock-up, after the stakeholder engagement meeting, we'll be able to have an estimate on what we really need there to make it okay for like a physically disabled person to be able to use. So hopefully in the future, not too long, we'll be able to have that kind of estimate to know. But then with whatsoever we are trying to do, the main motivation is that, okay, we are trying to get people who don't have much money to be able to get something that works for them. So that's like the main motivation for us. So I don't think we'll ever decide to go in for something that will just shoot the price so high. Yeah. Thank you very much, bro.
Thank you very much. We are going to be ending. I'm going to give all of you an opportunity to say your last words to our audience. We'll start with Catherine. Catherine will be dropping soon. Cathy,
Hey,
it's been
Joey.
awesome having you here. Any word for our audience?
Thank you. And thank you. I just want to acknowledge the presentations that came after me. I think the need to design affordable assistive technology locally and locally produce that is really necessary. And I look forward to working with the team in the future and to support any of the designs if as needed. And also just to mention that we will be producing local languages communication aids, and we'll be trying to organize a number of hackathons in Ghana next year, both with Jerry's team and at the University of Ghana. So it will be it's an exciting time, I think, in Ghana. There's a grassroots swell in work there. So this time next year, there should be more to say. Thank you very much for the opportunity to be here.
Thank you. Thank you so much, Cathy. Let's move to Betty. Your last words, please.
Thank you very much, Prof. I hope that from today, we would all appreciate the fact that disability is an issue we should all pay attention to. And when we see a disabled person on the way or on the road, we should remember that anything can happen at any time. It can be due to sickness, it can be due to an accident, anything. So let's try and support them to make their life more comfortable. Thank you.
Thank you very much. Dr. Ahene, please. Emmanuel.
Okay, thank you very much, Prof. First of all, I just want to say it's been a wonderful time I've had here listening to the various presentations, and especially also the presentation from Prof. Catherine. And basically, maybe just for us all to remember that truly inclusive healthcare is not just a goal, but it's a responsibility. And it's something that we all must embrace and work towards it. And so as a team, we are very, very much serious about ensuring that we contribute our own quota to ensuring equitable access to healthcare through these interventions. Thank you very much.
Hey, thank you too. Mr. Dixon Ofosu Mafu. Take it away.
Okay, so thank you, Prof. So one final word would be my team and I are actually very excited at this particular project. And I made mention during my presentation that our goal is not just to develop a solution that will just sit and rust on a shelf in the corner of our lab, but actually one that will be used by the persons who it truly matters to. So this is an interesting, should I say, in quote, challenge for us, but it's something that we are trying to develop for people who we want to see them using it and being happy with it, putting smiles on people's faces. So, oh yeah, an exciting journey ahead of us. Thank you very much.
Thank you very much. I go to Dr. Justice Owusu Ajiman. Joe.
All right, Prof, thank you. I want to thank everyone for joining our webinar today. And what I'll say to end is that nobody's going to save us. I guess we have to save ourselves. So we have to do our best to make sure that we create solutions that will actually force people to do the right thing, right? Because whatever thing we are trying to do is not something that is way above us. I mean, with the right money, things can get right. So we have to drive it and then later force people to do the right thing. So this is like one avenue for us to be able to draw people's attention to something they might have missed for a long time, and also see that, like what Madam Betty said, trying to help those who have scarred challenges. It's also one of the things that we should be focusing on, and then we've left it there for quite a long time. And then AI is a solution, a tool that is supposed to help us solve this. Thank you very much.
Thank you, Joe. And so our parting words, let us make the world a better place, making sure that we are leaving no one behind. This has been the Responsible AI Network Africa, working closely with the Responsible Artificial Intelligence Lab and the Global Disability Initiative Hub of the University College of London. We want to say a very big thank you for making time to be part of this, and we look forward to engaging you even more in the first quarter of next year when we have our next RAIN workshop. At this point, I will hand over back to Caitlin to take us away. Caitlin, please.
Thank you so much, Jerry. Thank everyone for this really interesting conversation. I certainly learned a lot, and I wish you all a joyful rest of the year. And again, that we'll see RAIN Africa and its activities. Please keep following on LinkedIn and Twitter to learn about our events and activities next year. And watch also for this video will come up in the next weeks as well. The recording will be available on our social media. So thank you all again and enjoy the rest of your day. Thanks to the panelists. Bye, everyone.